Good day, viewers, and you are welcome. How to find the value of a in this algebra, where we have a squared plus a squared divided by a plus 1 all square equals 3. So to solve this, if we consider this as divided by 1, it means we are going to find the LCM. So we multiply this with this, and we have a square into bracket of a plus 1 all square plus a square divided by a plus 1 square equals 3. So here is what we have. And next, we are going to expand this so that we have a square at the bracket of the expansion of a plus 1 squared. It gives us a square plus 2a plus 1 in bracket, then plus a square. Everything divided by a plus 1 square equals 3. So when we expand this, we are going to have a square multiplied by a square. That gives us a raised to power 4 plus, when we multiply a square with the whole of this in bracket, suppose I take it out and I have it as a square into bracket of 2a plus 1. So still the same thing, then plus a square, all divided by a plus 1 raised to power of 2 equals 3. So with this one, we have this as a square and this also a square. So we have a to the power of 4 divided by this. By separating it, we have a to the power of 4 divided by a plus 1 raised to power of 2. Then plus, so here is a square and here is also a square. Suppose I factor it out. So here we are going to have this as 2a plus 1. And when we factor this out, it also gives us 1 in bracket. And all this also divide a plus 1 raised to power of 2 equals 3. So if it is close to this stage, a to the power of 4, we can write it as a to the power of 2 raised to power of 2 divided by a is a plus 1 raised to power of 2, then plus, we have this as a square, open bracket, 2a plus 1 plus 1 gives 2, divided by a plus 1 raised to power of 2. Everything equals 3. So next we have this as a to the power 2 and here is a plus 1 to the power of 2. So we can let this one becomes a square divided by a plus 1, then all raised to power of 2, because both of them they have power of 2. Then we can apply the law of indices here, plus here is our a to the power of 2. So between these 2a and 2, we can just say we factor out 2. Then here remains a plus 1 bracket divided by a plus 1 raised to power of 2. But raised to power 2, it means we can still multiply it as a plus 1. Everything equals 3. So next we have this cancelled. When it cancels, we have this as a to the power of 2 divided by a plus 1 all raised to power of 2 plus, so here we have 2, then multiplying a square divided by a plus 1, everything equals 3. So what we have here is, this is a square over a plus 1 and this is a square divided by a plus 1. It means we can just try to replace it as, suppose we let beta equals a square divided by a plus 1. So anywhere we see a plus 1, we are going to replace it with beta. Then we have beta square plus 2 beta, then everything equals 3. This is a quadratic equation, as we have beta square plus 2 beta equals 3, where we can have this as beta square plus 2 beta minus 3 equals 0, and it forms a full quadratic equation. And we believe that this is factorizable, because when we factorize this, we have this as 2 and we have this as 3. We can just say 3 minus 1, it gives us 2, and 3 times minus 1, that gives us 3, which means the factorization of this one gives us beta plus 3 close bracket and open bracket beta minus 1, everything equals 0. So here is the factorization of what we have above, and the root of them are beta equals minus 3 comma 1. So this is what we have here, and having this, which is not the solution, so just try to come here as where we let beta equals a squared divided by a plus a, and we replace it. So for the first case, we just say when the value of beta equals minus 3. So we try to replace it as we are going to have a squared divided by a plus 1 equals minus 3. And when we cross multiply, what we have here is x squared equals minus 3 into bracket of a plus 1. So with this one, we have a squared. When we take the whole of this and open the parentheses, we have this as plus 3a plus 3 equals 0. This is what we are going to have for this. So looking at this, we can just solve this by completing the square method or formula method, because this is not factorizable as it looks. So what I'll do here is, suppose I say a square plus 3a. Suppose I add plus 3 divided by 2 square, and I also subtract 3 divided by 2 square. So plus 3 equals 0. So we have to combine this together, and we have it as a plus 3 divided by 2 all square. Then here is plus 3 minus 3 square is 9, and the 2 square is 4. Everything equals 0. Then we have a plus 3 divided by 2 raised to power of 2. So 4 multiplied by 3, that is 12. And 12 minus this, we have this as plus 3 divided by 4 equals 0. So with this one, we have a plus 3 divided by 2 raised to power of 2 equals minus 3 divided by 4. So when we take the square root of both sides, we have a plus 3 divided by 2 equals plus or minus square root of minus 3 divided by 4. So here we have a equals minus 3 over 2 plus or minus. So we separate this as square root of minus 3 divided by, so square root of all, it gives us 2. But square root of minus 3 is a complex root, and we have a equals minus 3 plus or minus I root 3 divided by 2. So we consider this as a1 comma a2. And again, for when the value of beta equals 1, so we also recall from where we have a square divided by a plus 1 equals 1. So the cross multiplication of this one gives us a square equals a plus 1. Then we take this here, we have a square minus a minus 1 equals 0. So with this one also, we are going to solve this one, and by applying the formula method. So let's us just be diversified and apply different approach to solve problem. So suppose we have this as a squared, we have this as minus a, and a is plus 1. So the formula we are going to apply here as the parameters we are going to need as. So I call this one a already, and in this formula I'm going to apply, we still have a here. So don't be confused, as I'm going to be applying this as, I called it a prime, the one I'm looking for. Then minus b plus or minus square root of b square minus 4ac divided by 2a. So a here is the coefficient of, b is the coefficient of a, and the a here is the coefficient of a squared. So c is the constant value. So by substituting, we have a prime equals 1 plus or minus the square root of, so b is still our 1 square minus 1, so it's still plus, then minus 4 times this, everything give us plus 4 divided by 2 multiplied by 1, that is 2. So the whole of this give us a prime equals 1 plus or minus square root of 5 divided by 2. And here is our real solutions to this, as a is our 1 plus or minus 5. So don't forget that it is not a prime. So what we need to really here is the value of a, but to avoid confusion, that's why I make it to be a prime. So we have a plus or minus uh 1 plus or minus square root of 5 divided by 2. These are our a2 comma a3. So this is how we solve this problem. Thanks for watching, and if you are new here to this channel and you find this video helpful or interesting in one way or the other, please do well to like, subscribe, and turn on the notification bell just to be aware of when we upload new video. See you in the next class. Never stop learning. Bye bye.